Okay, next 11th one. From the graph, the value delta C by delta T and the value of rate of reaction at X represents. So here graph is plotted between concentration and time. Okay, and we obtain this type of curve which indicates rate of reaction gradually decreases with time. And delta C and delta T, it indicates the rate of the reactants, okay, which is called average rate of reaction. Average rate of reaction is equal to delta C by delta T, okay. So delta C by delta T is average rate of reaction. And at a point X, okay, at a particular instant, rate of reaction calculated is called instantaneous reaction. So X represents instantaneous instantaneous rate of reaction, and delta C by delta T represents the average rate of reaction. So option A is correct. Average rate is represented by delta C by delta T, and instantaneous rate of reaction is represented with X. Okay, option A. Next, activation energy depends upon. So, four different factors are given here. Pressure, concentration of reactants, concentration of products, and nature of reaction. So, generally activation energy is independent of pressure and concentration. Okay, it depends upon the nature of the reactants. Okay, option D. Next, what is the rate of the following reaction? 2A gives B. Okay, with respect to A, we can write rate as minus 1 by 2 dA by dt. With respect to B, plus dB by dt. So, this is the rate of reaction for reactants and products. Okay. So, here rate of reaction for reactants is given. So, minus 1 by 2 dA by dt, concentration of A by con. So, this is the option. Next, for a reaction, half A gives 2B. Rate of disappearance of A is related to rate of appearance of B by the following expression. Okay. So, if you write rate of reaction for this, here half mole is there, and here 2 moles are there. Okay. So, we can write 2 dA by dt, which is equal to 1 by 2 dB by dt. Okay. Then, here in the given options, here A is considered as 1 mole. If it is 1 mole and formed products becomes 4. Okay. So, here rate of the reaction is given as minus dA by dt, that is equal to plus 1 by 4 dB by dt. Okay, minus concentration of reactants A by dt, that is equal to 1 by 4 concentration of B by dt. So, this is the correct option. Okay, next. For a reaction, A plus B gives C plus D. This is reversible reaction now. The forward reaction is exothermic reaction. So, here forward reaction is exothermic reaction. When forward reaction, this is exothermic reaction, activation energy of formation of A plus B. So, reverse reaction, backward reaction is always greater than formation of C plus D. Okay. So, it is greater than that of formation of C plus. This is concept oriented. Okay. Next. 16th one. For a reversible reaction A to B, which one of the following statements is wrong from the given energy profile diagram? So, this is the graph plotted between energy and reaction coordinate. We get this type of curve here. Okay. Then, here this curve indicates activation energy of forward reaction is greater than backward reaction. So, that is correct. Activation energy of forward reaction is more than that of backward reaction. Next, threshold energy is less than that of activation energy. So threshold energy is always greater than that of activation energy and also energy of normal molecules. It is greater than that of normal energy of reactant molecules and also activation energy of the molecules. So that's why this is wrong option. Okay. And you can check remaining options also. Forward reaction is endothermic and activation energy of forward reaction is equal to the sum of enthalpy of the reaction and backward reaction. Activation energy of backward reaction. Okay. So here we can give the formula. EA of forward reaction is equal to delta H plus EA of backward reaction. Okay, that is the formula there. Next, consider endothermic reaction EX to Y with activation energy EB and EF for backward reaction and forward reaction. So in general, activation energy of backward reaction is always less than that of the forward reaction. Activation energy of forward reaction. Okay. So that's why EB is less than EF. Okay. EB is less than EF. Next, 18th one. An endothermic reaction A to B has activation energy X kilojoules per mole of A. If energy change of reaction is Y, so energy change means this is enthalpy change. It is Y. Then activation energy of reverse reaction, activation energy of backward reaction, that is equal to activation energy of forward reaction minus enthalpy change. Okay. So activation energy of forward reaction, what is activation energy of forward reaction? X. And enthalpy change is given as Y. So this is equal to X minus Y. Okay. Next. Increase in the concentration of reactants leads to the change in, this is also concept base. Increase in the concentration of the reactants leads to the change in collision frequency. Okay.